Hello, I'm back again. As promised, I'm now going to review the digestive system. So in the last video, it was kind of an overview of all of the systems. And again, the systems of our body work together to create the total functioning organism. And what they do is the systems working together create what we call is homeostasis. And homeostasis is a very fancy word that just means maintaining balance in our body so that our body can function. So easy examples of homeostasis are things like our body temperature. Our body temperature is usually, the average is around 36 degrees Celsius, which is about 96, 97 degrees Fahrenheit. So if you get above that, I think it's about like 38 degrees Celsius or 99 degrees Fahrenheit or above, that is considered a fever. So our body wants to maintain that average body temperature so that all of the parts of our body can function, because that's the temperature where we function. When you get really, really ill, and if you get a really, really high fever, I'm talking 104 and over Fahrenheit. Sorry, that's the American in me knowing the Fahrenheit. You can actually die from having a fever that high. And the reason is because all of the proteins that are in our body that help keep us alive, these special chemicals, can be rendered inactive with a really high temperature. So they don't work anymore. So if you don't have the chemicals in your body working, well, then your body shuts down. So that's one example of homeostasis, keeping our body temperature at a relatively average level. And the way our body does that is, if you get really, really cold, you start to shiver. And that shivering is actually your muscles contracting. And that shivering sensation actually causes your body temperature to rise because your muscles are working. When we get really, really hot, we know that we sweat. And that sweat is a cooling mechanism, because as our body works to make that sweat evaporate, well, as our sweat evaporates, the heat that was locked in our body evaporates or goes away with that sweat. So there you go. Okay, so that was a little aside. I did say that I was going to talk to you about the digestive system. So let's take a look. So this is a very simple diagram of the digestive system. And the overall function of the digestive system is to break down our nutrients, or our food, I should say, into molecule-size nutrients that can be used by the rest of our body. Okay, so I think in your PowerPoint, I looked at the overall functions of the digestive system and put them into certain words. So the first function is called ingestion, and that just means taking food into our mouth. Next is digestion, which means breaking that food into molecule-size nutrients that can be absorbed into our blood, which brings us to number 3, absorption. Absorption means that those nutrients leave the actual digestive tract and enter the blood, because then the blood is going to be able to carry those nutrients everywhere that they're needed in the body. That's absorption. And then finally, egestion, which means anything that doesn't get taken into the blood, that's waste. And the waste is going to be excreted through our bowels, right? So that is the feces that we eject from our body or get rid of from our body. That is also part of the digestive system. Okay, there are 2 different types of digestion: physical digestion and chemical digestion. Physical is just making the food into smaller little pieces. And chemical digestion is when the molecules the food particles, are broken down into new molecules. So it's just like chemistry. Remember when we talked about physical change and chemical change? Physical change, you have the same substance. It's just smaller pieces. Chemical change, we're really making new substances. So things like fruit are actually broken down into fiber and glucose being sugar. Okay? All right, so digestion begins in the mouth, also known as the oral cavity, and both physical and chemical digestion happen in the mouth. Your teeth chew up your food, make it into a smaller piece, but your saliva also starts the chemical digestion. The saliva breaks down starch into smaller carbohydrates. Okay, so by the time that you chew up your food and it gets mixed with saliva, it is called a bolus. And that bolus travels along our digestive tube. And what I want to just take a little break to mention is that your digestive system is just one long tube. If we could unravel it all, it would be one long tube. And if you were unraveled it, it would probably go from one side of the room to another. It's, oh gosh, I want to say, I don't want to give you the wrong measurements, but I know we did this. If you think of one of our classrooms, we did a little experiment where, depending on your height, we could calculate how long your digestive tract is, and it would go from one end of the room all the way to another end of the room. So it's very, very long. That is called the digestive tract, okay? And that's where the nutrients, the food, is actually going to travel along as it is broken down. There are also accessory organs to the digestive system, and I'll get to those a little later. The food never enters those particular organs, okay? The food stays within the digestive tract. Okay, so this part of the digestive tract where the upper kind of part of our throat, that's called the pharynx. And the pharynx actually leads to two tubes. The tube of the digestive tract is called the esophagus, but the tube that's kind of laying in front of the digestive tract is called the trachea. And if you touch right here, you can feel these little rings of your trachea. Your trachea is part of your respiratory system. So we'll talk about that a little bit later. But that pharynx, the very, very upper part of your throat, it can lead to both of those tubes. So when we swallow, the trachea is actually covered over by a flap so that food won't get into it. Because what happens when food gets into your trachea? Well, you choke. And that can be really, really serious if it blocks your windpipe, because then you can't get your oxygen into your body. So that's when, you've probably heard of the Heimlich maneuver when someone's choking to try and dislodge that material that's stuck in the trachea that shouldn't be there. Okay, so literally when you're eating, sometimes you'll start to cough a little bit or something. And have you ever heard that expression, oh, it went down the wrong tube? Well, it really has gone down the wrong tube. We want food to stay in this tube right here, which is called the esophagus. Now, the esophagus is made up of muscle tissue. And remember, muscle tissue can contract. So it contracts and creates these waves so that the bolus is pushed down into the stomach, which is right there. There's the stomach. This is not the stomach. This is the liver. We're going to get back to the liver later. Here's the stomach right here. And the stomach contains acid and enzymes, which are special chemicals that break down the food. And the acid also breaks down the food into smaller and smaller pieces that are going to be able to eventually get absorbed, okay? So the stomach is also made up of muscle and these very special lining of the stomach. It has these ridges that are called rugae. And the rugae, when the stomach is not full, the stomach kind of collapses because it's a muscle, and those rugae can kind of rub against each other, and that makes that grumbling noise that you hear when your stomach growls. So that's really, your stomach is really empty. The sides of the stomach, or the parts of the stomach, are rubbing against each other, the walls of the stomach, I should say, and it's saying, fill me up. And as it gets full, it can expand because it's a muscle, and muscles can stretch. So that's your stomach. It's also interesting that your stomach creates a mucus lining so that the acid that's in the stomach doesn't actually eat through the stomach wall. And sometimes you can get a bacteria that can cause that mucus to not be made anymore. And if that mucus is no longer made, then the acid can start to eat through the stomach wall, and it's very, very painful, and that's called an ulcer. Okay, those are my little sides. Anyway, so now the bolus comes into the stomach. It gets more and more digested, both physically more and chemically, and it is now called chyme. And this chyme enters into the small intestine area. Digestion finishes up. Oh my goodness, I have to go to a meeting. Sorry, I'm going to